All attendees are in listen-only mode.
Good afternoon, everyone. This is Tori Schneller at Gardner Business Media, and I will be your webinar moderator today. Welcome to our webinar sponsored by Gibbs & Associates. Thank you for joining us. Our topic this afternoon is 5-axis technology. Does it make sense for your shop? The advantages of 5-axis machining can be significant, including both cost and time savings with a direct impact to a shop's bottom line. Certain parts with extremely complex shapes require full 5-axis motion in order to machine all required areas of the part, and other parts benefit from 5-axis positioning and can be machined in a single setup with greater accuracy and in less time. Multitask machines, MTM, can also make use of 5-axis machining in conjunction with conventional milling and turning operations. This webinar will demonstrate many of the advantages of 5-axis machining, including various application examples and how participants can benefit from the use of this technology. Our presenter this afternoon is Bruce King. Bruce's career in manufacturing began when he was working part-time and summers during high school. While completing his degree in electronics engineering, he continued working at a manufacturing facility where he advanced to a manufacturing engineer and implemented the company's PC-based CAM system. Later, after relocating to the Southeast, the opportunity arose to switch from CAM user to CAM reseller. With experience in several CAD/CAM systems, Bruce was approached by Gibbs & Associates in 2005 and accepted a position as applications engineer. Currently, he focuses on the 5-axis capabilities of GibbsCAM. As we listen to Bruce during the presentation, please feel free to share your questions with us by typing them in the questions pane on your control panel. He will answer those questions at the end of the presentation. This webinar is being recorded, so you will be able to view the entire program online later. Thanks again for taking time to be with us for the live program today. Here's Bruce.
Well, thank you, Tori, and thanks for everyone for taking the time to join us this afternoon. As we look at this rather broad topic of 5-axis technology, today we'll be discussing a brief overview of the 5-axis machining in general, what the primary types of 5-axis machine configurations are that you may encounter, what some of the benefits of 5-axis machining are, and also some of the challenges that might come because of 5-axis machining. And then finally, some of the typical 5-axis machining applications and programming techniques that we use to program these 5-axis machines. Okay, so now we'll start with a brief overview. The 5-axis segment of machine tool market is definitely expanding. In fact, some would say that it's the fastest growing segment of the machine tool market. The selection of machines is greater than ever before. If you go on basically any of the major machine tool manufacturers' websites, you'll see a selection of 5-axis machines of some sort or another. There are more lower price machines than ever available. Many of our first-time 5-axis users start off with a lower priced machine because it's easier for them to get into this technology. And then you can always move up later as you get more involved with the 5-axis. 5-axis machining, it's not just for large high-tech companies anymore. In years past, it would be the big aerospace companies and all that would have the money to spend on these very expensive machines, and there would be very expensive custom software to help program these machines. Well, that's not the case anymore. Machines are more affordable. There's more software. CAM software such as GibbsCAM is very affordable for 5-axis. So it's not just the large companies anymore. It's general machine shops that can get into this technology. Also, as product designs evolve, there's more complex parts that are required to be manufactured. If you keep up with the CAD market at all, you'll notice that that software market is growing leaps and bounds. All kinds of tools for designers to design more complex parts. They're trying to make more efficient parts, lighter weight parts, greener parts in this age of green, and all of these end up being potentially more complex parts, and then you in the machine shop need to find a way to manufacture these. All right, so what is 5-axis machining? Again, this is too large of a topic to cover in full in a setting such as this. So we want to limit the scope of what we're going to discuss. So for our discussions today, let's set some guidelines. When you hear me say the term 5-axis machining, I'm talking about a machine with 3 linear axes and 2 rotary axes. And by an axis, we mean a controlled programmable movement either along or around one of the 3 major axes. So if I can program G1, X3, and you can put that in the machine and the machine will control that axis, then that's what we consider an axis. The A, B, and C rotary axes will rotate about the X, Y, and Z axes respectively. So as you can see in this diagram, A rotates around X, B around Y, C around Z. This is the standard configuration. Now there are a few machine tool manufacturers that may deviate from this for one reason or another, and it can get a little confusing. But regardless of what the label is, the standard is like you see it here. Also, when we consider 5-axis machining, it's when we're using the machine axes in one of the following ways. Simultaneous, where all 5 axes are moving at the same time. So this is when you go to a trade show, you see a part, it's very impressive, it's moving all 5 axes all over the place. This is simultaneous machining. It's great when it's necessary, but there's times when it's not necessary and you actually should not machine this way if you don't need to. Another type is what we call 4+1. So this is 4 axes moving simultaneously. One rotary or tilt axis is locked in position. So for various reasons, we're locking one of the fifth axis and only 4 moving at the same time. This is also, some machines actually have this limitation. So even though there are 5 axes on the machine, you cannot program more than 4 in any given line of code. And then finally, what we call a 3+2. There's 3 linear axes functioning as a 3-axis machine, so just like you were using a regular 3-axis mill, but the rotary axes are locked in a 5-axis position. So we position the part, and then you treat it at that point as a 3-axis machine. So we'll go over some of these types a little bit later on in the presentation. So let's go ahead and we'll do some of the primary 5-axis machine types. First, we need to note that there is no such thing as a standard 5-axis machine configuration. You cannot go and contact, say, 3 machine tool dealers and say, I want a quote on your standard 5-axis machine. Because there is no standard, and even if one of those has an in-house standard, it won't be what the competitor's standard is. So 5-axis machines are built in many different ways for very different reasons, for doing any particular type of part or type of machining. So there is no standard 5-axis machine configuration. So what we want to do for today is limit it to 3 primary 5-axis machine types. So the first is a table. So this is a rotary and tilt table. So both rotary and tilt motions are performed by a dual rotary table. And then we have a head table. So we have rotary motions performed by the table, but the tilt motions are performed by the head. And then finally we have a head-head machine. So here both the rotary and the tilt motions are performed by a rotary head. Okay, so we'll look at these a little closer one at a time. So let's start with the table 5-axis machine. This is the most common type of 5-axis configuration that definitely that I come across. Most of the time, if I'm being contacted to help someone with a 5-axis machine, it's generally a table configuration. It's usually implemented using a dual rotary or a trunnion table. So you can see pictured here we have there's a dual rotary here, or over to the right here we have more what we call a trunnion, where it's attached in two places, and this style, which is actually part of the machine, would be much more stable versus one that you just add on to the machine. Rotary table is often added to a 3-axis machine. So rotary table, separate mechanisms that you can purchase, such as pictured here. Many people get started in 5-axis machining by taking an existing 3-axis machine and adding the 4th and 5th axis to it. And it's a good way to get started into the 5-axis technology. And so for all of these machines, the workpiece is the thing that is moving, so it's rotating around the tool. The tool does not rotate at all. And finally, a rotary unit must handle the weight of the part and the fixture. So the limitation here would be part size, obviously, to fit, and it also has to handle the weight of the part and any of the fixturing that you use to hold the workpiece down. That full weight is totally on this rotary unit. Okay, so some common configurations you'll see of this type of table machine. AC vertical is probably the most common. So the C-axis rotates around the Z-axis, and the A-axis tilt rotates about the X-axis. So when you'll hear me through the presentation say rotary and tilt, rotary and tilt. So what's the difference? Rotary axis is normally the axis that has full 360 degrees or more rotation. It can just spin all the way around. Where the tilt axis is normally limited. So the machine pictured here, normally a machine like this would have a limited tilt amount that it can go, so that it can travel, say, forward maybe 90 to 130 degrees, but the other direction towards the back of the machine maybe only 10 to 30 degrees because you have the limitations of the machine, the sheet metal around it, etc. So then you also have a BC vertical. So again, the C-axis rotates around the Z-axis, but now the B is tilting around the Y-axis. So some machines like the one pictured here, you have a little more freedom of movement in both directions, where it can move an equal amount, both plus and minus, a lot around the B-axis. Okay, the next type of machine is the head table machine that we mentioned. So this is the most versatile of the three machines as far as the types of work that you can put on it, and versatility as far as reaching to the different areas of the part. Because you're just dealing with a single rotary table, it can normally handle larger parts and heavier parts because you don't have that extra rotary mechanism that has to support this one and makes a weaker link in the chain, if you will. Okay, on this machine you would have the spindle head now would pivot, so where the tool is, that tool would pivot along one of the axes. So it's a combination of both rotary types. So some common configurations of this one would be, like we see here, is an AB vertical, where the A-axis is a rotary and the B-axis is a tilt. You probably don't find these as much as, especially in metalworking, as you used to before, and I'll explain that in just a minute here. We have a BC vertical, so the C-axis around the Z again, and then the B-axis tilt. And then we have the BC MTM, and this is one reason why you don't see the AB type that often, because multitask machines, what we call MTM machines, have just evolved and are used quite a bit, and we deal with these all the time. And they're very powerful because you can go ahead and combine all your turning ops and your milling ops, and then because you have that turning spindle that's also a 5-axis rotary, then we can use this as a full 5-axis machine. So normally for long parts like you see here, you can support the part. This is a very good configuration for this style machine. And finally, we have the head 5-axis machine. So these usually have a much larger linear travel for larger parts, but the rotary axis travel can be limited normally because of the way the machine is constructed. There's actually hardware in the head or wiring, and so that rotary can only go so far, and you'll actually start pulling pieces apart. So they can't allow that to happen, so they have to put a limit on the machine. So now you get involved in having to keep track of that rotary and pulling away from the part, rewinding if possible. So it can get a little complex. And obviously it's not as a strong machine, especially when we're talking about metalworking, because of the rigidity of the head versus working on a more rigid like head or head table machine. And on this machine, the workpiece is stationary, so all the rotary movement is in the tool spindle. All right, so those are the basic types of machine configurations we'll come across. And now let's discuss some of the benefits. Why would we want to get into this 5-axis technology? The first thing is reduce time and cost. So one of the big benefits, and especially if you're just doing what we call 3+2 machining, there's fewer setups. And of course, fewer setups means you have less work holding and overall lower cost. Less custom fixturing needed. So if you have a part that you have to really orient at some odd orientation, odd angle, you may need some custom fixturing to do that. But if you had it on a 5-axis machine and did it in a 3+2 mode, you could easily orient that part to whatever place you needed, and it would all be in 1 or 2 setups and no special fixturing needed. And of course, less setups means you less labor time spent on the setups and the more time your machine is running. You can also get some faster cutting times for more aggressive cuts using shorter tools. So we have a lot of benefits, which we'll be discussing, of using shorter tools. So with a 5-axis machine, you can tilt the part again to get clearance from the tool spindle and able to use shorter tools. Shorter tools mean it's more rigid and you can get more aggressive with your cutting. You actually also have control of the tool contact point, which improves tool wear, and of course greater tool wear saves you money. So by forcing the tool to cut towards the outside where it's more efficient at cutting, you'll get better cuts and better tool wear. You can also have improved accuracy with 5-axis machining. Because we have less setups, the more setups you have, the more potential error, because each new setup can introduce error. So you'll have a stack up of error the more times you reset this part up. So setup error can be eliminated basically if that part can be cut in just one setup, which is the ideal situation. Again, using shorter tools. If you use shorter tools, you can also improve your precision, because the tool is more rigid. And again, controlling the tool contact point, that also improves repeatability because you're just making a better cut. We can also have improved quality. So again, using shorter tools, you're going to reduce the vibration, and then your finish is going to be better. And once again, the control of the tool contact point improves the surface finish, because again, if you picture a ball mill, if you're just in 3D, we're apt to be cutting most of the time with the tip, which is the worst place you can be cutting with a ball mill. But if we can tilt that tool with respect to the part, we can get it cutting on a more desirable, larger diameter portion of that tool. And the last benefit here is to be able to expand your capabilities. So first off, some complex parts that can only be cut in 5-axis. There's certain parts that it's the old saying, you can't get there from here. The only way you're going to be able to do that is with a full 5-axis cut with a 5-axis machine. But some parts, they're only profitable if you can reduce setup. So let's say you have a long time relationship with one of your customers, but he's also having other people bid for that part, and you've taken all the time you can out of that by you're sure using the best tooling and you're cutting it as fast as you can. But if you're doing it at multiple setups and the shop down the street has a 5-axis machine and can do it in one setup, you can only reduce that charge cost of that part so much, and you're not going to make any profit. So if you can expand your capabilities to 5-axis machining, you can make parts more profitable. And this is a good one: gain more quote opportunities and customers through expanded capabilities. And again, I come across this a lot because we often have a customer that will become a 5-axis customer because of a particular job. Again, a relationship with one of his customers. You got the opportunity to cut something you normally would, and that requires a 5-axis machine. They give you the job, you make the investment. Well, once you've got that all figured out and you're up and running with your 5-axis, now you have that 5-axis setup that you can quote jobs that you normally would have to pass on. Okay, now 5-axis machining certainly isn't just a magic button and without its challenges. So obviously machine complexity. Machine is more complex, so there's some kinematics related issues. So kinematics is how we describe the relationship of all the axes moving together on a particular machine setup. And there's certain things that are unique to different setups that can cause problems, and those things you have to learn, and those things you have to be aware of. You have to know to not set up a part a certain way on a certain type of machine because these problems will exist. So there is a learning curve there where you have to learn these the complexities of the machine. Potentially a smaller work envelope. So when you even though you have a table and a full XY travel on a given machine, well, now when you limit what size part you can get on that rotary setup with your fixturing and all, without hitting some of the rotary equipment, now this size just gets smaller for you. So you have a potentially smaller work envelope to work with. You have additional collision avoidance. No one likes to crash a machine. It's definitely turns out being a bad day when you do that. Well, when you're dealing with 3 axes, you've got 3 axes to worry about. Now you're adding not only 2 more axes, but they're not moving linear, they're rotating. So there's more things going on, more things that can crash potentially, and obviously you have to get used to those additional things and learn how to avoid those. Programmer knowledge. You do need to know how to program in 5-axis. A 5-axis machine is useless unless you're sending it good 5-axis programs. So there is a learning curve for the programmer and for the operator and setup person as well. Again, knowing how to set parts up and how that particular machine is the best used to cut the parts you're cutting on it. All right, so now what we want to do is go over some of the 5-axis machining applications and programming techniques that can be used to help program these machines. So you've made the investment, you've got this new 5-axis technology in your shop. Well, now what? You need to program it, and that can be a challenge if you don't have the right tools to do so. So I like to, if we think of this a CAM system such as Gibbs CAM, as the whole thing as a toolbox. So guys out in the shop are used to using the toolbox every day. So we have our drawers, and we have 2D toolpaths, 3D toolpaths, 5-axis toolpaths, etc. So we're going to limit our discussion today mostly to the 5-axis toolpath drawer. So when you open that drawer now, we break that up into sections. So if you've ever worked on your own car, I like to work on my own automobile sometimes. You have your standard everyday tools, your wrenches and your screwdrivers and sockets and things that you use for every day. But you look in the repair manual, and you'll be something, and you'll go through and see, oh, well, now for this particular task, you need special tool number, blah, 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 blah. So this special tool isn't always necessary. Sometimes it is. You won't get it done without it. But many times we find ourselves with workarounds to try to not use that tool, which often take longer, don't get the job done as fast, they don't get it done as well, a lot more effort on our part, but we can get the job done. So it's very similar with the 5-axis toolpaths. We have a standard, what we'll call a general set of tools that you use every day and get the job done, but then there are some specific tasks that we have some specialized tools for, and if you use those tools, those are apt to make things much easier for you. So within our CAM system, we have many different toolpath strategies, or what we call patterns, for a large variety of part shapes. We have a full set of tools for controlling tool orientation. This is a biggie because you've got this machine now that's got these two extra axes you're not used to, and they're moving in a rotary direction, not linear, and you need to be able to control those. You also want to not only be able to detect collisions or gouges, but you need to correct them. It's a nice thing to know that there's a gouge, but it's a better thing to know that there's a gouge and then be able to do something about it automatically and let the CAM system take care of that. When we use cut part rendering or machine simulation, we want to do that so we can check the tool at our computers, check the tool path, what it looks like, what the part would look like before we get it out moving on that machine. And of course, customized post-processes, especially for 5-axis machines and MTM machines, are critical, so that post-processor is tailored especially for that particular machine. All right, so let's look real quickly at 3+2 machining. This is still probably the most popular type of machining you will do on a 5-axis machine, even though it's nice to watch things moving around like I mentioned before. There are many reasons to use 3+2 machining, and you will, again, without going to parts that require 5-axis machining, you can still gain so many benefits by going to 3+2 machining. So when you hear the term 3+2 machining, it's also known as 5-sided machining or 5-axis indexing or 5-axis positioning. When you hear someone say any of those terms, we're all talking about the same thing. 5-sided machining comes more from if you plot the cube up there and you have the 4 sides of a cuboid plus the other end. I don't like that term because it sounds like you're limiting it to 5 sides, whereas you look like a part here on the screen that has, you know, the top and around the OD, plus you've got 6 flats on there, so you have more than 5 sides, and it's not limited to just 5 sides. So the rotary and tilt, your 4th and 5th axis, are positioned, and then they're locked. And most machines, there is actually a lock code, like an M code, that you will put out to physically lock that in position. And since those axes are locked, then it's more accurate than simultaneous because those axes are not free to float at all. They're locked in place and they won't move. So this is more rigid and is actually the best way to rough whenever possible. So even if you are working on a full simultaneous 5-axis part, it's whenever possible, it's still best to use 3+2 to rough, because it's, again, a much more rigid setup, and you can place this part in several positions and do the roughing from those positions. So in GibbsCAM, when we do something like 3+2 machining, the point I want to make here is that when you're moving from 2- and 3-axis machining to the 3+2 machining, when you're using a system like GibbsCAM, it's really not much of a step at all. So the only other piece we're adding here is we're going to define a coordinate system, and in a part like this you can see I have a face highlight. That's really all we need to do. Highlight the face, put a coordinate system on, and we're ready to go. There's other options like automatic feature recognition that will also automatically find the coordinate system of the holes, and because this is a very symmetrical part, we really only need the one face, and then we just rotate the toolpath around to the other faces. So there's very little extra work here. Once you have a face defined, all programming just now becomes a simple 2.5 3D like you're used to doing. And the CAM system will worry about what that 5th axis orientation is and output the proper code to put it in the right position. So it's really quite simple, and again, not much of a step from normal 2.5 and 3-axis machining. So if we did this part, just for example, on a BC vertical mill, we'll just step through a couple screenshots here of obviously the first thing, the tilt and rotary will position to the first flat. We'll do some face milling, and then we'll repeat for the other 5 faces, and then it's just that same repeat for the drilling, and then we're done. So again, very simple, and the programming aspect of that was very minimal because the CAM system is doing the work for you. But yet we were able to do that part all in one setup, and it's finished one setup off the machine. Okay, another technique we use is 5-axis drilling. Has some similarities to the 3+2. But if you have a part with many uniquely positioned holes, so where we'd have to create a bunch of coordinate system, this allows us to kind of skip that step and just say, okay, here's my complex part with holes all over the place. Just go grab each hole, put the machine in the right position, and drill a hole there. The drilling position and motion uses up to the full 5 axis, so this will obviously depend on how the holes are oriented and also what type of machine you have, what axes are available. So the position and motion are based on the whole centerline vector. So again, either found automatically through feature recognition, or you don't even need a model with holes. We can even take just faces or surfaces, and you can plop a pattern of holes around it or on it and just pick the holes and say, I want these all drilled normal to the surface. So it can be very simple to do many holes in a 5-axis motion. And all the holes are referenced from one coordinate system. So unlike what you might do with 3+2 and choose several different coordinate systems, in 5-axis drilling, we just would reference them all from one. Okay, so now we'll look real quickly at the general functionality. So like I talked about the toolbox a little earlier. So we open that 5-axis drawer. So the largest part of that drawer is going to be the general functionality. So we have many patterns that we can choose from to create the toolpath, point-to-point toolpath pattern we want on the part. So we have a robust set of tools for all these toolpath patterns. It's comparable to a 3D surfacing strategy. When I train people in 5-axis and they're familiar with 3-axis, I try to get them to think about the patterns just as a 3-axis toolpath. Let's forget about the 4th and 5th axis at this point. Just get the pattern that you want onto the part, and then we'll worry about how we tilt things later. And you can use reference geometry to control the flow. So if you're often using other surfaces and faces or curves, like in this case where we're morphing the shape from one side of one of these fins to the other side, and that's how we determine our shape of the toolpath or the pattern. Okay, tool axis control. This is a very important one. Again, you've got this new 5-axis technology. You have these two rotary and tilt axes that can move all over the place. You need to have control of that. You can't just have it go anywhere, and you need to minimize how much it moves, and it needs to only move for a particular reason. So we need a robust set of tools for controlling the tool orientation. There's many things you can do with this. It can be fixed. I want this tool to just stay here at 30 degrees, for instance. It can be varied. I want it to start at 30 degrees on this side of the part. By the time it gets to the other side, I want it to be maybe minus 30 degrees, so you can have it vary. You can also constrain it by geometry. So point the tool axis through another piece of geometry like a line or a point or a curve. You can also control the tool contact point. So like we said earlier, we can gain speed and accuracy and all from controlling what part of the tool we use to cut. And with our tool axis control in our software, we can take control over what portion of that tool is actually used to cut material. And very importantly, each rotary and tilt axis can be limited. You're going to have many setups where even though the machine can go full one way or the other, the part you have in there and the fixturing will not go that full amount because it'll collide with parts of the machine. So you want to be able to control and contain your amount of tilts. Okay, and again, as we mentioned, gouge check. We have a full set of tools for gouge check and correction. I can't overemphasize that because again, it's good to know if you have a gouge, but better to go ahead and correct it and not have a gouge. So here's kind of an extreme example, but here's a part where we're trying to run this tool through this odd-shaped channel, and you can see we're not doing a very good job of it. So now if we tell the CAM system that we want it to get through there automatically without gouging, it will fit that tool through there automatically with the clearances we specify and avoid any gouging of the part. Okay, so now just want to go over a few of these more specialized things. So again, we looked at the toolbox, and we looked at the bulk of the everyday general tools that we'd use for 5-axis programming. But now we have a few little smaller compartments that are these special tools that we need. And one is swarf machining. So if you're not familiar with the term swarf machining, it's just basically saying that we're cutting with the side of the tool. And you'll also hear it called flank milling. That's another name for the same thing. So we can either select the cutting surfaces or maybe just an upper and lower curve to follow, or both, depending on what strategies we're using. And the range of tool axis control is anywhere from very manual user defined like tilt lines or to fully automatic. So I can just tell the system to automatically control the tilt, or I can get real specific and actually have lines drawn like you see in this graphic, these green lines. So when the tool hits that particular point, it'll be oriented exactly in the direction that you specified. So again, we like to do things automatically when we can, but we never want to get away from giving the programmer full control over each toolpath. And this is just a quick example of what a swarf toolpath would look like. Okay, and 5-axis swarfing is something that we do a lot of. You'll see that a lot with 5-axis technology. Okay, another one of these programming techniques, special techniques you get tucked away, is toolpath projection. And this helps you improve the quality of a toolpath on, number one, problem models. You may just plain get a bad model, which, let's face it, it happens sometimes. Or maybe the model was from scan data. Someone did a scan on this model, so it's not really clean. And the 5-axis will pick up on all these little differences in normals and all, and give you some movements that you don't want, and make it difficult to have a nice clean finish. So we can do a few tricks here and kind of constrain the tilting on shapes with extreme variations in normals, or if it's a bad model. So one of these ways is an automatic way, and it uses a system-created cylinder as its basis for the calculation. So what we do is just, without drawing anything, it's a virtual cylinder, if you will. I just give it some numbers and tell it what the cylinder toolpath should look like, and then I pick the part, and then it automatically takes that toolpath projection on that part. So now this part that would normally give me a problem if I try to use it from my general set of tools, now it gives me a very nice clean toolpath and does it in a very simple fashion. So the results of something like that would look like this. So this is really a 4+1 toolpath, and notice we've tilted the 5th axis to get that ball nose off of its tip. Okay, and there's also a little more manual way of using our gouge correction strategies to use the same programming technique. So a part like we see here, if we just stayed normal to it, it would tilt too much, we'd get collisions, we'd have excessive movements as we're going over those humps. It just would not be a good toolpath. So what we can do is kind of similar. We just instead put a toolpath on a simpler shape, one that's flatter, doesn't have as much slope to it. Then we select the portion we want to machine, and then the gouge check puts the toolpath down onto that part for us and creates a better toolpath. So again, it's when we come across this situation, it's another one of these special tools that's in the drawer for us to use to get this type of programming done. Okay, another type we have, which is very powerful, is 3 to 5-axis conversion. And just as the name implies, this converts a 3-axis toolpath to 5-axis. So the main benefit of this, where this gets used most of the time, is allows for shorter tools to be used. So if you're trying to cut a deep cavity, or you've got a tall standing core, and you don't want to use a long tool, then you can use a shorter tool and just use whatever favorite 3-axis toolpath you like to use. But then we can use this automatic method of 3 to 5 conversion to automatically tilt the tool away from this part when we're going to collide. So the attic mode only converts to 5-axis when necessary. So we can have it stay 3-axis until it needs to be 5-axis. So basically, as we're coming down in a 3-axis toolpath with a shorter tool and a part like this, at some point this holder is going to collide. And so when the conversion takes place, you can see on the right there that the tool is tilted away from this part, and it now clears the part. So it's now transformed from a 3-axis toolpath, and it's now changed when necessary to a 5-axis toolpath. Okay, and you can see that here. So here we're running in 3-axis, but when that holder gets to where it will collide, now we'll start tilting automatically. And one of the benefits of this, again, is there may be 3-axis strategies that you prefer to use for a particular reason. You can still go ahead and use those, but just then add the benefit of the 4th and 5th axis when necessary. So it's a very powerful tool. Okay, and finally here we've got two very special tools, if we will, very specialized. Our first is multi-blade. So this is specialized option for turbo machinery parts. And it simplifies the programming of impellers, blisk, and bling. So any kind of a bladed part, a rotary bladed part, programming is much easier, or sometimes only possible with this type of tool. It has a targeted interface, so it's easier to use because we use terms that you're used to using with this style of part. So instead of just picking machining surfaces, for instance, it'll ask you to select the blades. So terms that are used with this particular style of part. And so it makes it very easy to pick the portions that you want to cut, to rough, finish the blades, duplicate around to finish the entire part. So again, it's a very targeted tool made specifically for this type of part. And we're actually finding more and more people cutting impellers. It's like 5-axis technology. It's not just for the big companies anymore. The same thing with this. Smaller companies are finding new jobs coming that are impellers that they never thought they would be doing impeller work. Okay, and then the last tool we want to go over is specialized, what we call 5-axis porting. So this is mainly for engine ports, manifolds, throttle bodies, but it also allows, like the part on the left, because it's extreme, has a curvature, it has a very large shape on the top, small on the bottom. That's tricky with our standard tools. So again, if you have a specialized tool for that type of part, you'll get a much better toolpath. It'll make it much easier. So some of the features of this is superior toolpath quality. Again, much easier to program. You have the condensed user interface because we don't need to look at all the tools in that drawer available. We're only looking at this small section of things to get this type of part done. It'll do roughing and rest roughing, spiral and plunge finishing. So plunge finishing will go down and back out the port. All tilting is automatic. So as you can see, the tool going down on this port, it only starts tilting when it needs to, when it knows it's going to collide. And I don't have a set of tools of tool axis control because I don't need it. It does everything for me. It cuts in 3-axis when possible. So again, no need to move the 4th and 5th axis unless it's necessary. And it also automatically calculates the max tool reach. So you can see now it's seen how far it can get down. It went as far as it could go, and now it's automatically coming into the other side. It's in 3-axis mode now, and now it's moving in the 5-axis to avoid collisions. It knows how far it was able to get through the previous side, so it's going to go up and a little past that to blend the two toolpaths together. Again, all automatically. Okay, so in conclusion, 5-axis machining can improve profits, which that's the bottom line why you'd want to invest in this technology. We can reduce setup time. We can improve part accuracy and the quality. We can reduce tooling costs, not only because of tool wear. When you have 5-axis reach, there's times where you can just use, for instance, just a normal straight end mill instead of a tapered mill, because you can use the 4th and 5th axis to get that tapered angle for you. And again, like I see all the time, you can open up new opportunities with greater machining capabilities. So if you have that technology in your shop, you're going to be able to quote on more jobs and potentially get jobs that you otherwise wouldn't have been able to get. 5-axis machining requires CAM software for effective use. I mean, this is a must. You can only do so much with a 5-axis machine if you don't have the tools to properly and effectively program it. In a system like Gibbs CAM, you have a powerful range of functionality from 2 to 5-axis milling. And again, the 2 and the 3-axis is important for the 3+2, because like I mentioned earlier, except for the positioning portion, other than that, we are just doing 2.5 and 3-axis milling. We have full 5-axis milling support for NTM machines, so not only can it do all your turning and mill turning, but add a step further, we can do full 5-axis milling. You want it to be easy to use and flexible, be able to work with it your way, not be limited by, rigid steps that you have to follow. And you want to be able to get customized post-processors for your 5-axis machines. Okay, and that's what I have for my presentation today, and I thank you all for listening in.
That was very interesting, Bruce. Thank you for your very informative presentation.
You're welcome.
We have got some questions from our audience, so I'd like to go ahead and get started with those. In the meantime, for our attendees, please feel free to submit your own questions by typing them into the question pane on your control panel at the right hand of your screen. We'll get answers for all of your questions, even if we don't get to them while we're on the air. This webinar is being recorded and will be available online, so if you can't stay for the whole session, you can catch up later. Okay, so our first question is, with 3+2 machining, is it possible to cut 5-axis features without using 5-axis strategies?
Sometimes yes, because what you can do is position in 3+2, and even though it'd probably be more efficient to cut a given feature in 5-axis, but if you can reach it, then you can apply a 3-axis toolpath to it. So even if you were only using 3+2 technology, you could position, you'd have to get the right position and then treat that feature as a 3-axis feature.
Okay. Second question, I don't have any 3-axis machining needs. Would 5-axis still benefit me?
Okay, so I'm assuming by 3-axis needs, we're talking about 3-axis point-to-point pass, like in mold making and all. So if you don't have the need for that, yeah, the 5-axis tool pass still can help in areas like, again, 5-axis drilling. You may need to use swarf cutting. So there are some non-point, what we call point-to-point pass that you can use without needing the full point-to-point 3-axis.
Okay. Number 3, does 5-axis require special tooling? Can I use the tooling I already have?
Yeah, in fact, more so you can use the tooling. That's one of the benefits, because obviously if you're cutting engine heads or something, you're going to want to use lollipop tools or something, maybe a little special. But for 5-axis machining, a lot of times, like the swarf machining, you'll get away with using a standard flat tool instead of buying a taper tool. Or if the taper is some non-standard angle, you can still use a taper tool, but you don't have to worry about having the exact taper angle. You can create that angle with the 5th axis capability.
Okay. And let's move on to, I already know and am comfortable with 3-axis machining. How difficult would it be to jump to a 5-axis machine?
You've got a good head start if you're comfortable with all that. And again, it like we mentioned, some of the challenges, you do have to get used to what's going on with any given machine, what you can set up, where the kinematics issues could arise. But as far as, as the programming, the point-to-point stuff is very much the same, and now you just add the tilt and the gouge check onto it. So yes, there's a learning curve, but if you're very comfortable with that concept of 3-axis machining, the transition should be fairly simple.
Okay. You mentioned CAM software plays an integral part to the success of 5-axis machining. Are all CAM systems equal when it comes to 5-axis machining, or are some better suited than others given the application?
Yeah, given the application is the key point there. For instance, Gibbs CAM, our main focus is production machining, even though it's not used exclusively for that. So we always want to tie up everything in the scope of you're still turning and milling, and you're still trying to get quantity parts out, and you're still trying to cut these parts as quick as possible. So we want the 5-axis to work, within that realm, and that would be opposed to if you were just a prototype shop, just making all these crazy shapes, and you only made one, and you didn't really care so much about machining time and all. Then there could be a system that's better suited for that. So yes, we have pretty much many of the same capabilities, perhaps as of another system, but we try to put that all in the package of overall all the tools you need to be a very efficient production shop.
Okay. In machining pockets and drilling holes in 3+2, you made it look very simple with the automatic specification of a coordinate system. Is this unique to Gibbs CAM, or does everybody do that?
I know everyone has some form or way they deal with coordinate systems, and I can just say because I've used many different ones, the variety of ways we have for you to simply just tag things off a model and say that's where I want my coordinate system or how I want it to be aligned is just very simple. So I just find it, again, I think the task of doing that is very minimal, and it's a very minimal additional step from going to 3-axis to 5-axis 3+2 machining.
Okay, it looks like we have time for one more question. Are there any benefits for 3-axis machining with 5-axis software?
Depending on the capabilities, yes, there are some things. Our 5-axis software, you can actually lock down axes. So I can run it in a 5-axis mode. I can run it more in a 4+1 mode or a 4-axis mode, or I can actually run it in 3-axis mode. So because of the way it operates, there are some benefits with, say, like undercutting and that type of thing. And some tool path patterns are a little different. So what I can tell you is we do have customers that have the full 3-axis and 5-axis, and there are definitely cases where they have preferences in certain situations that they like to use the 5-axis toolpath even in the 3-axis mode.
Okay, well, Bruce, I want to thank you again for presenting these slides and taking the time to answer all of our questions. For those of us attending this afternoon's session, you can contact Gibbs & Associates if you'd like to touch base with them for some more information. Bruce's contact information is on the screen. If you missed any of the previously broadcast parts in this series, you can find all of them on our website, MMS Online, under the Webinars tab. We really appreciate the time you've taken with us this afternoon, and I hope you found it worthwhile. Thanks for taking part. My thanks also to those who arranged the session and helped it go smoothly. This concludes our webinar. Have a great day, everybody.